Okay, so by the time you see this, you will have worked a couple of problems of this nature that lead you up to what I'm talking about here. Okay, so Q of 1 equals, we'll write it out this way, 0.9 times Q of 0. Because our growth rate is negative 0.1 every time, every day, we multiply what we started the day with by 0.9. Basically, you're losing 10%, so you're retaining 90%. And what we're interested in is what you're retaining. So after one day, you have 0.9 times whatever your initial quantity is. Okay, then Q of 2 equals 0.9, and I'm not going to use parentheses, 0.9 times Q of 1, which is, of course, since Q of 1 is 0.9 times Q of 0, it's this, so it's 0.9 squared times Q of 0. Q of 3 is 0.9 times Q of 2 equals 0.9 times 0.9 squared times Q of 0, which is 0.9 cubed times Q of 0. Now, do we see a pattern here? It should be pretty obvious that every time we multiply the previous by 0.9, so if we start with 0.9 squared times Q of 0, if we multiply that by 0.9, we're going to get 0.9 cubed times Q of 0. So now we can at least conjecture that Q of 4, we're going to increase the power of 9 by 1. We get 0.9 to the 4th times Q of 0. Okay, now we can fill in blanks here. I mean, it's going to be 0.9 times Q of 3. Q of 4 is going to be 0.9 times Q of 3. Q of 3 is 0.9 cubed times Q of 0. So yeah, we're going to multiply this by 0.9, giving us another factor of 0.9, giving us 0.9 to the 4th. So Q of n is going to be 0.9 to the n times Q of 0. Now, this is not a formal proof. A formal proof would involve what's called mathematical induction, which is something that I think should be taught as part of pre-calculus. But nobody's going to listen to me on that. I learned it in high school before I had a pre-calculus. Of course, I never had a pre-calculus. They just slapped me into a very rigorous calculus course, which caused me to grow up a lot. Okay, well, anyhow, that's me. Okay, so there we have it. Okay. And there's our expression for Q of n. Now, I use n here because n is a whole number of days. None of this applies to what happens in between. Okay? And what happens halfway through the first day? What's Q of 1.5? This model doesn't give it to us, but we can conjecture if this is a continuous rate of change, and if the one-day rate is negative 0.1, then when I said rate of change, what I mean if the continuous growth rate Okay. I hadn't thought this through. I thought it was a good time to say it so I don't have the right words. If a continuous growth rate results in a daily growth rate results in a daily growth rate of r equals negative 0.1, then q of t equals 0.9 to the n times q of 0. And now t could be any time measured in any fraction of a day rather than in whole days. Okay? Now we make that distinction because whatever the quantity is, it might not change until the end of the day. It might come along and stay constant through the day and then all of a sudden drop by 10%. Do this and drop by 10%. Okay? If it's a continuous growth rate, that's not going to happen. It's going to change very smoothly and continuously throughout the day. So, the next question is if q of 0 equals 100 and q of 1 equals 91, find the exponential function that models I should have said q of t, referring back to our q of n. Now where do I get the 100 and the 91? Well, right here. Started at 100, dropped to 91 after the first day. Okay? So we're going to solve this one.